Hello everyone. Now we are going to discuss about parallel glass slab. What is the refraction through the parallel glass slab? In this concept, how the refraction takes place. Again, by using this concept, what are the things we are going to discuss? The first one, we are taking this in A, B, C, D is the one rectangular glass slab, and AB is the first surface, CD is the second surface. If the light is incident on the first surface, the angle of incident is I1 at point O, and refracted in glass slab, the angle of refraction is R1. This refracted ray incident on second surface CD at point M, second angle of incident is I2. Again at point M, the ray is travel to the glass to air. Glass to air means the refractive index is decreases. That's why it bending away from the normal. Now this value we can say this angle second refraction. This is the first refraction. This is the second refraction. That's why I am writing R2. In this condition, in this concept, we have to discuss the two things. We have to discuss mainly the two things we can use for the sums to solve. Here the first one, in this condition, whatever this is the angle of incident and this one is angle of refraction in second medium. But according to this one, this we can say angle of emergent. Now we have to show that the angle of incident is equals to angle of emergent. And here if you use the according to mathematics, what will happen? These are the alternate angles. Alternate angles are always equal. R1 means this first surface of the refraction, angle of refraction is equals to second surface of angle of incident. These two are equal. Whenever these two are equal, then angle of incident is equals to angle of emergent. We have to show that. First one, to solve this one, first concept what we have to find out? Here the angle of incident is equals to angle of emergent. Okay, we have to show this one. If you want to show this part, what we have to take? Applying the Snell's law. Okay. Now I am writing according to Snell's law, where I am taking at point O. At point O, what we have to write? The sine of angle of incident. This is the sine of angle of incident. To sine of angle of refraction. The sine of angle of refraction in R is equals to mu2 upon mu1. The mu2 upon mu1. Say equation number 1. Okay. Now again we are applying the Snell's law same point at point M. At point M, angle of incident is I2, angle of refraction is R. But light is traveling from glass to air and mu2 to mu1. Now sine I1 I2 upon sine R2 is equals to mu1 upon mu2. Okay. Here the mu1 upon mu2. Here what we have now? Here say equation number 2. In this two equation, therefore from equation 1 and 2 we get what I am taking? Equation 1 multiplied with equation 2. Now mu2 upon mu1 into mu1 upon mu2 is equals to, what I have to write here, sin I1 upon sin R1 into sin, now here this value, this product is equals to constant. Why? Because this method we can say principle of reversibility. What is that? The product of refractive index is equals to constant, that is called principle of reversibility. Now substitute this all values, then here what we can write, sin I1 upon sin R1 is equals to, now here it is equals to 1. Now this equation, one more step I want to write here, the mu2 upon mu1 is equals to 1 upon here, mu2 upon mu1 we can write. Now these values have otherwise here 1 upon mu1 upon mu2. Substitute these two values, equation 1 and equation 2. Equation 1 is sin I1 upon sin R1 is equals to, here mu2 upon mu1. Here 1 upon 2 means this is a reciprocal. Now sin R2 upon sin I2. Now this will be cancelled. Sin I1 is equals to sin R. This is sin I1. Here I0 is equals to angle of incident. Then R2 is nothing but angle of emergent. This angle of incident is equals to angle of emergent. How we can conclude that? For example, the angle, the 45 degree, the angle is incident on the AB surface with 45 degree. And what is the angle of refraction? The I1 is equals to R2, it is a 45, automatically it is also 45. This is our first concept, the angle of incident is equals to angle of emergent. Okay, now they are going to discuss the second concept. What is the second concept? Now the second one we have to discuss now second one we can discuss in this concept. What is that? Lateral shift, or we can say internal shift or lateral displacement. Where we have to get this lateral shift or lateral shift? Here, see the diagram. If this absence of AB, there is no AB surface, that time what will happen? This incident ray should travel like that. Okay. Now we have to draw the one perpendicular line from emergent ray to incident ray. Now here I am drawing the one perpendicular line. This is the perpendicular line. Now at this point I am considering M dash. Here M is there, that's why I am taking M dash. This M dash is called lateral shift. Now this part I am extending up to here. This is the O. Now I am considering this part is O dash. Now this value, this is angle. This angle is rho. This rho is equals to what we can write after I will give the clarity. This angle is rho, angle of deviation. Now we need to find out what is a displacement. This is the drawn perpendicular to the incident ray. O M dash, we need to find out that M dash is nothing but lateral displacement or lateral shift or internal shift. Now you take the one triangle. Now we have to consider the triangle O M dash. O M dash. In this, what is angle? Rho is there. Now I am considering sine rho. Sine rho is equals to opposite upon hypotenuse. That opposite we can say M dash upon hypotenuse. This is a hypotenuse O M. Now therefore M dash we need to find out, that is a lateral displacement. Then O M sine rho. Say equation number 1. But here OM we don't know. This is a lateral displacement, we know that. OM we don't know, and rho also we don't know. For example, now to find the OM, again you have to consider to find the rho also. How we can take in this alternate angles? According to alternate angles, I1 is equals to what we can write? R1 plus rho. Similarly, the rho is equals to I1 minus R1. This is the rho value, we got it. Again, now we have to consider the another triangle, that is O dash M. O dash M is the another triangle. In this triangle, what is the angle? Angle is the R1. Now I am using the cos ratio. Cos R1 is equals to what we have to write the cos value? Cos value adjacent upon hypotenuse. The adjacent value we can write O dash upon O M. Therefore, O M is equals to O dash cos R. Here O dash is nothing but thickness of the glass plate. This is a thickness of the glass plate. Now here we can write, this is small t. OM value also we got here. Now this OM value, say equation number 2. From equation 1 and 2 we get, from equation 1 and 2 we get M dash is equals to this value, what will have? T upon cos R. Now T upon cos R1 into sin I minus R, means I1 minus R. Here the day M dash is what is the lateral displacement? We are assuming that D. The D equals to, this is a lateral shape. D is equals what is that? T upon cos R1 into sin I1 minus R1. This is the formula for lateral displacement. In this lateral displacement, we can take the two cases. The first case, note point. First note point, what I am taking, this is angle of incident is very small, approximately small. That time sin theta approximately theta. That sin theta equals what is that? Here directly I am writing I1 minus R1 approximately equals to I1 minus R1. But here whenever the sin value is small and cos value is approximately maximum or maximum value, the cos maximum value is 1. Now substituting the all values, D equals to what we will get? T into I1 minus R1. Now take a common I1, T I1 1 minus R1 upon I1. Whenever R1 upon I1, the theta is very small. Theta is very small means here what we can write? It is a ratio of angle of incident and angle of refraction. This value we can write B equals to Ti into 1 minus 1 upon mu. This is a second formula for lateral displacement. And the second one, second note point also we can discuss. If the angle of incident is, what is the second point? Second point we will discuss later. Now up to here, the angle of the lateral displacement is equals to Ti into 1 minus 1 upon mu. Mu is a refractive index. That value 1 is the air, mu is the glass. Here mu 1 upon mu 2 also we can write. But air we are considering, that's why 1, and this is a glass plate, we are considering mu. These two formulas are very important for all objective purpose. Now note down.